Dear student, in this video I am going to discuss properties of Z transformation. We will start with the property linearity. Here we can see if the Z transform of x1n is equal to z1 x1z and the Z transform of x2n is x2z, then linearity property says that the Z transform of a x1n plus b x2n will be equal to a x1z plus b x2z, where a and b are constants. Now let's start with the proof of this property. Here let xn is equal to a x1n plus b x2n. Now from the formula of Z transformation, xz is equal to summation n is equal to minus infinity to infinity xn z raised to the power minus n. Here we will put the value of xn from this equation, a x1n plus b x2n. We will apply summation over these two terms like this. Now this term can be stated as x1z and this term can be said as x2z. Now we get a x1z plus b x2z. Next property is time shifting property. In time shifting property, if the Z transform of xn is equal to xz, then the Z transform of xn minus k will be z raised to the power minus k into xz. The ROC of z raised to the power minus k xz is the same as that of xz, except for z is equal to 0 if k is greater than 0 and z is equal to infinity if k is less than infinity. Now we will start with the proof. Let we wish to calculate the Z transform of xn minus k. Now from the formula, xz is equal to summation n is equal to minus infinity to infinity x1n z raised to the power minus n. Let x1n is equal to xn minus k. So we will put the value of x1n here. Summation n is equal to minus infinity to infinity xn minus k z raised to the power minus n. Now let m is equal to mn minus k. So n will become n is equal to m plus k. Now in this equation we will put the value of m, then it will become xm z raised to the power, here it was n, so we will put n is equal to m plus k. Now the limit will become n is equal to, it was n is equal to minus infinity, we will put the value of minus infinity and then m will become again minus infinity to infinity xm z raised to the power minus m plus k. Now we will separate these two terms, power of z raised to the power minus m and z raised to the power minus k. Minus k we can take outside of this summation, then it becomes is equal to z raised to the power minus k summation m varies from minus infinity to infinity xm z raised to the power minus m. Now this term can be called as xz. So x1z becomes z raised to the power minus k xz. Next property which we are going to discuss is scaling in Z domain. Now in this property, if the Z transform of x1n is xn is equal to xz with the ROC mod of z is greater than r1 and less than r2, then a raised to the power Z transform of a raised to the power n multiplied by xn is equal to x a inverse z. Then the ROC will become mod a r1 is less than mod z is less than mod a r2. Means the region of convergence will be in between these two regions. Now we will start with the proof. Now here we will calculate the z transform of a raised to the power n xn. It will be summation n is equal to minus infinity to infinity a raised to the power n xn z raised to the power minus n. Now we will take a and z, a inverse z raised to the power minus n, and this whole term can be called as x a inverse z. Now here the ROC of xz is z is in between r1 is greater than r1 and less than r2. Now the ROC of x a inverse z will become a inverse z is greater than r1 and less than r2. Now this equation we can write like this: mod of a r1 is less than mod z less than mod a r2. This is the ROC of x a inverse z. Next property is time reversal. If the z transform of xn is equal to xz, ROC varies from r1 to r2, z is greater than r1 and less than r2, then the z transform of x minus n is equal to xz inverse. Here the ROC becomes mod z is greater than 1 upon r2 and less than 1 upon r1. Let's see the proof of this property. Z transform of x minus n will become summation n is equal to minus infinity to infinity x minus n z raised to the power minus n. Let k is equal to minus n. We can put in this equation k is equal to minus n. Then the limits will become k is equal to infinity to minus infinity x k z raised to the power minus k. Now this can be written as k is equal to minus infinity to infinity x k z inverse raised to the power minus k. Now this can be called as x z inverse. Now the ROC becomes mod z inverse is greater than r1 and less than r2. It can again be written as 1 upon r2 is less than mod z is less than 1 upon r1. Next property is differentiation in z domain or effect of multiplication by n. In this property, if the z transform of xn is equal to xz, then the z transform of n into xn is equal to minus z d by dz of xz. Let's start with the proof of this property. This is the equation of z transform xz is equal to summation n is equal to minus infinity to infinity xn z raised to the power minus n. Now differentiating both sides with respect to z, d by dz of xz summation n is equal to minus infinity to infinity xn. If we will differentiate z raised to the power minus n, then we will get minus n. Minus we have put it here, minus n z raised to the power minus n minus 1. Now we can separate it out, z raised to the power minus n into z raised to the power minus 1. Z raised to the power minus 1 can be written as minus 1 upon z. N is equal to minus infinity to infinity n xn z raised to the power minus n. This term can be called as z transform of n xn. This z can be multiplied here, and so this equation become minus z d by dz of xz is equal to z transform of n xn. Therefore, we can also written that if n raised to the power n into xn is there, then its z transform will become minus 1 into z d by dz of xz whole power n. In the next video, we will discuss some more properties of z transform. These are the references.